Today, the topic of our lecture is dynamic loading. Dynamic loading is a type of load whose magnitude is going to vary with the passage of time. It is opposite to the static load. Let's say this is a vertical beam and there is a load P exerted on this vertical beam. If the magnitude of this load P is not going to vary with the passage of time, then this type of force is called static load, and if its magnitude is going to vary with the passage of time, then this type of load is called dynamic loading. Now, why do we need to understand this dynamic load? The reason behind this is that if we design any machine element against static loading, and if we then apply that machine element with the dynamic load, then that machine element is going to fail before the yield point. So what we will have to do is to understand the dynamic load, and after the understanding we will have to design the machine element against the dynamic loading, so that if in future that element is subjected to the dynamic load, that element will not fail. The example of such element is spring loaded valve and piston and cylinder type compressor. Pressure inside the cylinder changes with the passage of time, so that is why the force on the that spring will also change with the passage of time. So we can say that that spring should be designed for the dynamic loading. Now these are the types of dynamic loading, and alternating load is a type of load where sigma max is not equal to the sigma minimum, and both have different signs as well. And for the fluctuating, the sigma max and sigma minimum is not equal, but their signs are the same, both have positive signs. And for the repeated load, the sigma minimum is equal to 0, and for the completely reverse type load, the sigma max is equal to sigma minimum, but the signs of sigma max and sigma minimum are different from each other. One is positive and other one is negative. Now to understand these types, we have a shaft, and this shaft, let's say, is subjected to a transverse load, and there is an axial load as well on the shaft. In fact, we have two bearings, and there is helical gear that is mounted on this shaft. Now you know that this helical gear will have a reaction on the shaft along the radius and along the axis of the shaft as well, and because of these bearings there will be reactions like this. These are the reactions on the shaft, and this is the torque on this shaft. Now we take this force and we want to see the stresses against this load. So to see the stresses in the shaft against these loads, we have the cross-sectional view of the shaft, and upon this cross section of this shaft we have taken different points: point A, point B, point C, and point D. In fact, we can also take a single point. Let's say we take this point A, and at this point A we can analyze the stresses developed for one complete cycle. Since this shaft is rotating, so when this shaft rotates with 90-degree, point A will become point B, and on further 90-degree movement the point A will become point C, and when point A cover 270-degree, point A will become point D. So what I mean to say is, whether you take different points or whether you take the angle, you will get the same result. Since this force is constant everywhere in the shaft, so it will produce direct stresses in the shaft, and they will have same magnitude everywhere in the shaft, like this. And after that, let's see the stresses produced in this shaft because of these loads. So you see that these forces are transverse forces. They will try to bend the shaft, and the shaft will bend like this, and due to the bending you can see that this part will be under compression, and due to the compression there will be compressive stresses, and this part is under tension, and there will be tensile stresses in this part. And as you move up towards the center, the tensile stresses go on decreasing, and as you move down from the top surface, the compressive stresses are decreasing, and when you reach at the center, both the compressive and tensile stresses are equal to 0. So you can see that this point A and point C both are on the central plane. So the bending stresses at this point will be equal to 0, and at point B there will be tensile stresses drawn in the positive direction, and at point D there will be compressive stresses drawn in the negative direction, like this. Now let's find out the general formula for the total stress at these points. So for that, total stress is equal to direct stress plus bending stress. Now at point A, you can see that bending stress is equal to 0. So total stress at point A will be equal to direct stress. And at point B, you can see this is the direct stress and this is the bending stress. So total stress at point B will be equal to bending stress plus direct stress. And at point C again, you can see that the direct stress is this one and the bending stress is equal to 0. So total stress at point C is equal to direct stress. And at point D, you can see that the direct stress is in positive direction and the bending stress is in negative direction. So total stress at point D will be equal to direct stress minus bending stress. Now, since we have obtained the general formula for these points, now we can have different cases. There are 4 different cases. First case is when direct stress is greater than the bending stress. The second case can be when the direct stress is equal to the bending stress, and the third case is when the direct stress is less than the bending stress. So these are first 3 cases, and another case is when direct stress is equal to 0. We will try to go with these 3 uh, cases first simultaneously, and then we will go towards this case. So first of all, draw the total stress in the y direction and in the x direction. There are these points A, B, C and D, or angle 0, 90, 180, etc. So whether you take angle on x-axis or whether you take these points A, B, C and D, you will have the same curve. Now you can see that at point A, for all these 3 cases, the stress at point A is equal to direct stress. So this will be the point in all these 3 cases. This is direct stress, this is also direct stress, and this is also direct stress. Now at point B, the bending stress is added with the direct stress. Let's say this was the direct stress and this was the amount of the bending stress, so total stress will be equal to this. So this is the point B for different cases. And again at C, the total stress is equal to direct stress. Now at point D, you can see that the total stress is equal to direct stress minus bending stress. So for the first case, when the direct stress is greater than the bending stress, it will give you some value greater than 0. And for the case C, that is when direct stress is equal to the bending stress. So here, let's say direct stress was 9 and bending stress was 9, both are equal, so it will give you 0 value. So when they are equal to each other, it will give you 0 value. So this is that point. Now for the third case, when the bending stress was greater than the direct stress, so when you put bending stress and direct stress in this formula, so smaller minus greater will give you negative value, so it will be somewhere over here. This is the point for the first case in positive direction. Then this is the point where the total stress is equal to direct stress. This type of stress is called fluctuating stress cycle. The definition of this fluctuating load is the sigma max should not be equal to sigma minimum, and both have same signs. So you can see over here, this is the sigma max, this is the sigma minimum. They are not equal to each other and the signs are the same, both are in positive direction. Now as I told you that for the case when direct stress is less than the bending stress, you will get total stress in negative direction. So this is the point, and again point I will be equal to direct stress. So this is the cycle, and this type of cycle is called alternating stress cycle, and the load is called alternating load, whose definition is that the sigma max should not be equal to sigma minimum and the signs should also not be the same. You can see this is the sigma max, this is the sigma minimum, and the sigma minimum is negative, sigma maximum is positive. So this type of load is called alternating load. And after that, for the another case where bending stress is equal to the direct stress, so total stress will be equal to 0. This is that point, and again at point A, total stress is equal to direct stress. So when you combine these points, it will give you this cycle, and this type of cycle is called repeated stress cycle. And the definition for this is that sigma max will have some value and sigma minimum will be equal to 0. Now after that, the fourth case is when bending stress is equal to some value and direct stress is equal to 0. So when you put direct stress is equal to 0, you will get the total stress at this point. At point A will be equal to 0, and at point B it will be equal to bending stress, and at point C it will be equal to 0, and at point D it will be equal to bending stress but in negative direction. So if you want to draw this, at point A you can see their total stress is 0, and at point B you can see the total stress is equal to bending stress but in positive direction. Again at point C total stress is equal to 0, and at point D total stress is equal to bending stress but in negative direction. And again at point A the stress is equal to 0. So you will get this cycle, and this type of cycle is called completely reversed stress cycle, and the load is called completely reversed load. And the definition is that both the sigma max will be equal to sigma minimum, and they will not have the same sign. One will have positive sign and other one will have negative sign. This is sigma max with positive sign, and this is sigma minimum with negative sign. Now in order to discuss which one will be the most dangerous force, so let's move on further. As I told you that whenever you exert a dynamic load, the body will fail before the yielding. Means that when there is no variability in the load, the body will show greater strength, but when there is variability in the load, the body will show less strength. So the variability in the load is responsible for the decrease in the strength of the body or machine element. So we need to quantify this variability in the load, and this variability can be quantified by the sigma variable, and it is equal to sigma max minus sigma minimum divided by 2. In all these four cases, whichever force gets the maximum value of sigma variable, that load will be the most dangerous load. For that, let's take different types of the stress, and for that find out the sigma variable and sigma mean as well. First of all, let's take the static load. For the static load, let's say this is the load or stress, sigma in this direction. This is the points A, B, C, D or angles in this direction, and you will find out that the stress will be constant everywhere at every point at any angle. So there is no variability, or in other case sigma max is equal to sigma minimum. So when you put sigma max is equal to sigma minimum, you will get 0 from sigma max minus sigma minimum. So it will give you sigma variable equal to 0, which is less than sigma max, and sigma mean will be equal to sigma max, because sigma mean is equal to sigma max plus sigma minimum divided by 2. So you can see that, let's say this is the sigma max and this is the sigma minimum. When you add these two and divide that with the 2, it will give you sigma max value.
Sigma max plus sigma minimum divided by 2 is the formula for the mean stress when we want to find out the mean stress at 2 points. But if we want to find the mean stress at 4 different points, so take 4 points where the stress is equal to sigma max or m in static load. So when you add these, it will give you 4 sigma max, and divide by 4 will give you sigma max. So mean stress for the static load is sigma max.
For the fluctuating load, you can see over here that this is the sigma max, this is sigma minimum. So when you subtract the sigma minimum from the sigma max like this, it will give you this, and when you divide it by 2, it will give you this, which is less than sigma max. And when you add sigma minimum with the sigma max like this, it will give you this value, and when you divide it by 2, it will give you this value, which is less than the sigma max. So sigma mean is less than sigma max. Then for the alternating stress, you can see that this is sigma max, this is sigma minimum. Sigma minimum is already in this direction. When you subtract the sigma minimums from the sigma max, this direction will get inverted like this. Let's say this is sigma max
And this is minus sigma minimum.
So in total it will give you this, and when you divide it by 2, it will give you this value, and this value is less than what? Sigma max. In order to understand it, let's take values. Let's say sigma max is 18, and sigma minimum is 9. So 18 minus 9, because sigma minimum is minus 9 divided by 2, that will give you 27 divided by 2, that will give you 13.5. And you can see that this 13.5 is less than this 18, which was the sigma max. So for the alternating, sigma variable will be less than sigma max. Similarly, sigma mean will also be less than sigma max, because sigma max is added with the sigma minimum. So 18 minus 9 will give you 9, and when you divide it by 2, it will give you 4.5. So sigma mean will also be less than sigma max. And for the repeated stress cycle, you can see that sigma minimum is equal to 0. So this is equal to 0. Sigma variable will be equal to half of the sigma max, means that sigma max will be 2 times that of sigma variable, or sigma variable will be less than sigma max, like this. And uh, for this case, sigma mean will also be half of the sigma max. After that, the final case is completely reversed cycle. For that case, sigma max is equal to sigma minimum. Let's say sigma max is 9 and sigma minimum is minus 9. So 9 minus and 2 minus 9 divided by 2. So this will become positive sign. So 13 divided by 2, it will give you 9. So sigma variable is equal to 9, which was also the value of sigma max. So sigma variable is equal to sigma max. And in case of this sigma mean, this sigma max is 9 and minimum is minus 9 divided by 2, that will give you 0. So you can see that for the
static.
sigma mean is the greatest value.
And for all other cases, sigma mean is less than from the value given by the static load mean.
And the variable stress is equal to sigma max for the completely reverse stress cycle. And for all other cases, the value of sigma variable is less than value of sigma variable for the completely reverse stress cycle. So we can say that the most dangerous load is this completely reverse stress cycle. So what we will have to do is to harness this load, or we will have to design the element against this load, and if we do so, our design will be safe for all other types.